So let's make a start. Yesterday we learned about gas laws and we discussed four different gas laws. The first one was Boyle's law, and Boyle's law stated that pressure is inversely proportional to volume given that temperature is constant. Then we talked about Charles' law, which said that volume is directly proportional to temperature and pressure needed to be constant. After that, we talked about Avogadro's law, which said that if the temperature and uh, volume is constant, then if the temperature is constant, then the pressure is directly proportional to the number of moles. Oh, sorry. What's the volume? Sorry. The volume is proportional to the number of moles. And in this case, the temperature and pressure has to be constant. Now, if you were to combine Boyle's law, Charles' law, and Avogadro's law, you would find that P, the product of pressure and volume, is directly proportional to NT. Does that make sense if you take these three? If you take P is inversely proportional to 1 over V, and you take V is directly proportional to T, and then you take this one, V is directly proportional to N. If I combine all these three, can I say that the product of P and V should be the product of N and T? Think about it. If the pressure goes up, the number of moles has to go up. If the number of moles go up, the pressure should go up. If the temperature goes up, the pressure should go up. If I keep V constant, as the number of moles go up, pressure goes up. If I keep V constant, as temperature goes up, pressure goes up. Okay, let's look at the other way of doing it. If I keep P constant, the pressure constant, then as I increase the number of moles, the volume goes up. If I increase the temperature, the volume goes up for a gas. Does that make sense? You just have to keep one of them constant and you'll see that it works like a charm. Does it not? So now combining all the three laws, we come up with this equation, and of course we have to change the proportionality sign to an equal to sign, which can be now written as PV is equal to KNT. Does everyone follow me till here? Yes? No? Maybe? Huh? So I've just changed the proportionality sign to an equal to sign and I've introduced a constant in this process. Now turns out that every experiment that you do in which you know the pressure, know the volume, know the number of moles, and have measured the temperature, if you calculate PV over NT for any gas on which you're conducting an experiment, that the constant is always the same value, and that's why we call it the universal gas constant, also denoted by, anyone knows what's denoted by? R. The value of this universal gas constant is, let's try to find the units. So R would be equal to P V over NT. What's the unit for pressure? Yes, but we want to use pascals, which is Newton per meter square. These are the SI units. We want to always restrict ourselves to the use of SI units. So Newton per meter square. Volume? Volume is length times length meter cube. Thank you. What about number of moles? What's the unit for that? Mole. Who said that? Good work, Rudy. Times temperature. Good. If someone would have said Celsius, I would have flipped. So meter square cancels off with the meter cube to leave meter. Does that make sense? Indices? Yep. Yep. So I'm left with just meter. So I'm just going to erase it now. So Newton meter. Now, does anyone know what Newton meter is? What is the other unit that we can use for Newton meter? Has anyone studied physics ever? Of course you have. I taught you physics. Work. What's the unit for work? Work is force times distance. Joules. What's the unit for force? What's the unit for distance? What's Newton's time meters? Joules. So the unit for gas constant is joules per mole Kelvin. You should know this in your sleep. Oops. Not very good. That's just the unit. So what is the value for it? This is a controversial topic because in your data booklet it says 8 point. What does it say in your data booklet? Does anyone remember? Huh? Oh, that's the volume. Sorry. That's the volume. In your data booklet, the volume they talk about is 22.7, whereas it should be 22.4. And I'll prove that to you. I've been waiting for this chapter in particular to prove the data booklet wrong. Anyways, the universal gas constant is 8.314 joules per mole Kelvin. Now, how did we get that? It's simple. You take every standard value, standard temperature and pressure. We take pressure and temperature at standard temperature and pressure. So for standard temperature and pressure, T is 0 degrees Celsius, or what's it in Kelvin? Thank you. 273 it is. 273 Kelvin. Pressure, which is the same as 101,325 Newton per meter square. Now, what's the volume? Well, according to the data booklet, it is 22.7 liters. But just for fun, I'll take it 22.4. Why? I don't know. I just want to get 8.314, which is the universal gas constant, which shouldn't change. If I take 22.7, it will change. It will be wrong. I hope so. I've put a lot of pressure on me now. So, volume is actually 22.4 liters, but we can't write it as 22.4 liters. Why? It is not the SI unit. So, what do? I write it as, how do I convert liters to meter cube? How many meter cubes are there in a liter? We have gone through this a million times, but I'll go through this again. 1 liter is 1000 centimeter cube. So how much is that in meters? Someone please tell me. What do I divide or multiply this by? God kill me. Oh my God. How do I convert a centimeter cube to a meter? By the life of me. No, you don't times it, you divide it. By what? 100 times 100 times 100. It's a centimeter cube. I'm not converting a centimeter to a meter by dividing it by 100. I am converting a centimeter cube, so I will divide it by 100 times 100 times 100. There is a centimeter cube, so how do I convert it? So can I write this as centimeter times centimeter times centimeter is centimeter cube. So It'll be 1000 divided by 100 times 100 times 100, which gives you 0.001 meter cube. All good? So our volume is actually, what would it be? 22.4 times 0.001, which can be written as, God, I think I'm teaching myself, 0.0224 meter cube. All good. Now, next step, how do I get the value of R? I know my pressure, which is 101325. I'm using the formula PV over NT. 101325 over Newton meter square. I know my volume, which is 0.0, what was it? 0224. 224. We can't forget to carry the units. Remember Raghu margin rule. Okay. Divided by the number of moles, which is 1 mole, and temperature 273.15 Kelvin. Tyler, would you be kind enough to put that in a calculator and get the answer? Thanks. So if you put the numbers in your calculator correctly, you would find that the final value is 8.31 joules per mole Kelvin, which is when we use a value of 22.4 liters. Unfortunately, if you use 22.7 liters, as one of my students just pointed out, it is 8.41 joules per mole Kelvin. Absolutely wrong. However, that's what your data booklet tells you to do, so just do it. I mean, there's no other way. Anyways, now I'm going to give you some time to write all this stuff down. So just take your time to write down. Thanks.